In this video, I'm going to teach you how I made this 3D printed back pressure valve. So this is the back pressure valve that comes with the Buzzbee bazooka, and mine broke, and when I opened it up, it seemed to be fairly simple, so I decided to just 3D model my own version. What you need is a three-way valve, and it has to be normally opened. So when there's pressure and the button isn't pressed down, air can flow through both ways. But when the button is pressed, the air on the top part of the valve escapes through the holes on the side, effectively maintaining the pressure on the input side and then making the pressure on the output side go to 0. So when air enters into the back pressure valve, it pushes what I call the stem forward, and because there's some soft material on the tip, it seals the hole and builds up pressure. And then when you close the three-way valve, the pressure on the output side goes to 0 psi, but that also creates a vacuum, so it makes the stem go backwards and it opens up the hole or the opening on the back pressure valve, which is what releases the air. So the first step is just to 3D print the models and then remove any Z-seams on both the body and the stem. And it's also very important to make sure that the stem and the back part of the back pressure valve are smooth. So here I'm just sanding off the male portion of the back part so that there's very little friction between the stem and the back part. And then here I'm just smoothing off the body again. And then for the soft material on the tip of the stem, I'm actually using flowable silicone. And then I don't know if this helps, but I try to remove any air bubbles. And unfortunately, I waited too long. So even when I let the flowable silicone settle, it still maintained a somewhat uneven surface. So here, because there's so much room between the stem and the male portion of the back screw, there won't be a vacuum when I release the air using the three-way valve. So what I do is I just get some tape and wrap it around and then try to get a somewhat snug fit, but you don't want there to be too much friction, because if there's too much friction, then the stem won't be able to move back and forth. And then here I'm just removing the extra, and at this point I think it should be fine. Next, I'm just going to add plumber's tape so that the back pressure valve is airtight. And my technique for putting on the plumber's tape for really short threads is to fold it in half. And so when I wrap it around a thread, it effectively acts as if it's 2 layers of wrapping. And then I just sort of twist the threads in my fingers to make sure the thread doesn't slip off when I'm screwing it into something. So now I just have to test it out. But for this first go, for some reason, the stem wasn't going backwards when I released the pressure with the three-way valve. So I thought I would maybe try using some WD-40 to reduce any friction. And you can even hear it, the stem being able to freely move back and forth, but still no luck. However, I did notice that if I assist the stem in going backwards by poking it with a screwdriver, it would kind of work. So I actually went through a few more trials, but they were basically the same thing, where the back pressure valve wasn't releasing the air through the tip. All the pressure was just going back through the three-way valve through the 2 side holes. So I thought maybe I would just remodel the back portion of the back pressure valve so that it was wider, and thus it would probably be easier to make something closer to a perfect circle. And also that would mean there would be more tolerance available to me so that the fit wouldn't have to be quite as perfect as when I tried using smaller diameter dimensions in the back pressure valve, if that makes sense. Because the one on the XBZ valve, the diameter of the male and female parts of the stem and the back portion are pretty small, so I thought I would do the same, but I guess I couldn't get that precise with 3D printed parts. And so I just made a bigger version. So here's just a tool that I made to ease the process of smoothing out stuff with sandpaper, and it turned out to work somewhat well. And then when I finally did all the steps over again with just new parts with different dimensions, it finally worked. So yeah, thanks for watching.